Hi everybody. Halfway through, nearly there, first day. Yeah, I'm going to talk to you about the cloud, where it's at, and this. People talk about hybrid a lot, and I'll talk to you about what I think the current state of the art is. So Daito, we're a Google Premier partner. So Google, you're probably aware, they're third place in the market in terms of being a cloud provider, and it's very interesting because they by far have the superior technology stack. They've got absolutely highest quality infrastructure you can imagine, and they use it for their internal systems. But they've been historically lousy at selling to the enterprise, and they're aware of this. So they're making a radical change, a radical push into enterprise. And what they're doing is they're partnering with close primary partners for the customer relationship. So what we are is a premier partner with Google, and we do the customer-facing services, and we know everything there is to know about Google stack. Randy, who's sitting here, wrote the certification program for Google, so we know it. And we've got a large customer base. We sell, resell, and provide consulting on the whole stack Google provide. And as I said, it's an interesting time in the market because Google are aggressively moving to catch up, and they're focusing on getting into the enterprise space. And it's not a question of technology, it's a question of providing that relationship, that enterprise set of services that are required to really move on. One thing they did, though, I don't know if you saw this in the industry, is two weeks ago at Google Next, they did something that was really a ballsy move. They set out to level the playing field. You guys probably have heard of something called Kubernetes. And Kubernetes it's an operating system. It basically provides all the plumbing to be able to deploy clusters of services across a generic cloud. And it's extremely powerful. And if you look around, it seems that everybody offers that capability. So Kubernetes can be run on AWS, can be run on Google, etc., etc. So what Google announced was something that changes the game, which is they recognize that this is now the x86 of cloud, Kubernetes. That's the baseline, everybody supports it. So if you build to Kubernetes, what Google are now offering is something called Anthos. And this is taking all of Google's expertise in managing Kubernetes in-house to manage your platform in the cloud. So this runs Kubernetes on-premise seamlessly, but you can then move to Google, but this is the groundbreaking bit, they will also move you to AWS or to Azure. So they're leveling the playing field completely. So if you just build to Kubernetes, Google can manage you and run you on whatever cloud platform. So suddenly you're not locked into one cloud stack, as long as you go with this open standard. So that changes the game, and Google are obviously serious about getting on level terms, and that's where things are at. So where do we come from? We have a deep expertise in Google technologies, but we also have a long history of kind of understanding the state of the art in terms of current architectural designs and cloud architecture. So some background from me. I've been doing microservices since actually before 2005. If you look on the Wikipedia, I'm the first person who ever started talking about microservices in 2005. But I've actually been working on that type of architecture since early 2000s. And what motivated me back then, I'm originally a physicist, and I got into software, and I started to find that I could try and I had a big ambition to build internet scale technology, and I had software And software was this scale, and the internet was this scale. And as I started to try and build stuff, the software became more and more brittle. And I started to find that you painted yourself into a corner, and the code became more and more brittle. The more you learned, the less you knew, the more you had to eventually throw it away and build another one. And I looked at that and I went, this is insane. This cannot be a good economic model for systems. We shouldn't have to throw things away when they get to a certain scale. So I started thinking about why the web works. And it wasn't why the web works as a technology, it was why the web works economically. What is it about the properties of the web that allow it to evolve? And that led me into thinking about microservice type of architectures and to understand what the web was in terms of the abstract model behind it, resource-oriented architecture. So that's my background. And again, we bring that in with Daito's relationship. Now there's a lot of hype, there's always hype in technology cycles, and the current hype is that if you're not using microservices, you're doing it wrong. And of course that's not true. What you've actually got to think about is there's an awful lot of engineering trade-offs, costs. You've got to make a balanced decision against many, many variables. And I think this is one of the axes to look at the problem. We're told monoliths are not the thing to do. And of course they have high software complexity, they're big lumps of code. And a microservice is a simple thing, right? It's a small amount of code and it's quite simple. We can get our heads around it and we build that. But if we look on the other side, a monolith is a trivially simple thing to operate. It's on or it's off. You can throw one over the wall and get it running very quickly. Whereas when you move to microservices, you're looking at a system and you have to think of us as a system architect, and you have many, many moving parts. And you have to think about the complexity of deploying and managing and understanding the state of services. So it's not trivial, it's not a simple trade-off. And for me, it's not a black and white. You basically, what you're always looking for is you're looking at what your capabilities are, what your team can do, what the choices of components you have. And often the answer lies somewhere in the middle. There's a sweet spot somewhere between, some intermediate scale. And then that's just one set of axes. There's always multiple axes. The other choice you guys have all got now is there's monoliths and microservices, and you're looking to get the balance there. And then this way, there's on-premise and cloud, and you're trying to understand, do I do new stuff at home and then move it to the cloud, or do I do all my greenfield stuff in the cloud? What's the partitioning of how I balance stuff? And of course, everybody's got legacy, so you've all got stuff that runs, wherever it was born and will die. So how do you deal with that world? Balance the two. And then on top of all of these dimensions of this problem that you guys are faced with and trying to solve every day, what you're really looking for is to try and minimize the cost. And the cost somewhere, there's a minimum in that set of variables that you're trying to find out. So it's definitely not a black and white question. It needs engineering analysis, needs to be understood, and each problem needs to be addressed and thought through. And one of the things that we're aware of, you need rigorous engineering, proper engineering, where you're doing cost-based analysis and saying, what are my cost benefits of doing this type of thing with the architecture? But the other thing you need, if you go to the cloud, is it's kind of easy to go down to your data center and feel the heat coming off the servers and know roughly how much you're spending, right? You can feel it. But in the cloud, nobody hears you scream, what is out there? Nobody knows. And it's very, very easy just to rack up exponential costs because somebody turns on the tap, leaves it running, and the bathroom floods and nobody knew. So one of the things we're doing with the blessing of Google is we're filling in the landscape of tools that enterprises need. So we've invested heavily in something we call Cloud Realtime, and this is an active measurement, monitoring, cost control system that gives line-by-line analysis of what your cloud spend is. More importantly, it allows you to set budgets. It gives you a prediction of where you're going to come in. It doesn't tell you retrospectively, like at the end of the month, oh, you've burnt your year's budget. It tells you on the, in the moment, hey, you're going to exceed your budget if you don't do something about this, and you're aware of it. And the other thing it does is pretty smart, is when you look at all the line items you've got across all the offerings that are available on all the cloud platforms, it's very easy to just turn everything on, lots of stuff. And what you find is that the spend across each line is usually correlated with some other line item. So what we do is we use machine learning to discover this service, hey, you just turned this off. Did you know these 5 other things were correlated? They're probably related. Do you want to control those too? So you can kind of get that understanding of where in this set of stuff you are using your money. And of course, it's not about, for us, it's not about helping you reduce your costs. It's basically saying if you've got insight and understand where you're spending money, you can be much more effective. You can engineer better because you know how your money's being spent. So that's the kind of background. That's what Daito offer. That's what we do. We have that deep understanding of the stack and how to move to the cloud and what the cloud means. And we also have in our pocket, we have a sort of way of thinking about services that is a differentiator against the market. So, who's heard of REST? Who's heard of APIs? Right. So all those who've heard of REST have jumped to the end and missed out the REST bit at the beginning, right? APIs, what an API really is a REST API. And what that means is you're exposing some of your information, some of your systems through an HTTP addressable interface. They're called endpoints. But the principle, the design guide that people are following with these APIs is they try to make them what's called RESTful. And REST, if you've not heard of the term, it's the underlying architecture of the web. Okay, so when your browser interacts with a website, it doesn't, the server doesn't grab everything, put it into a great big payload and send it all in one gob to the browser. The browser sends a description of a set of resources and says, if you ask for these things and compose them together, you'll get a view of the page. That's a late-bound, composite, resource-oriented architecture. And the fundamental thing about REST is that what you want is to have horizontal scalability, because you don't know who or what is suddenly going to become the most popular thing in your architecture. So it needs to be able to scale. And to be able to scale, the best design is to be stateless, to basically provide, every time you interact with the API, you have to provide all of the state for that interaction. And this is why it's called REST. It's called representation state transfer. So it's moving data to the code, doing something, and then going back to being stateless. So if you think about it, every API you ever write is it's completely it gets torn down to nothing. It has no memory. It's got no memory of what previous state was in. So you have to provide all the state. But that's great because you want to be able to scale it up onto a Kubernetes cluster and spin out many thousands of these things, and et cetera, et cetera. So it's a good design. From a system architecture point of view, it's also really great because the value of small services is that we don't know what we're doing most of the time. And as we start to build stuff, if you make it available service as a service and you let people be aware of it, other people can start to use the value of it. So the value of the web, the reason the web scales economically is because every time you add something, you gain value in the whole effect. So if you move to an API-based model for your architecture internally, the potential is that someone else will benefit from this. It's not hidden away inside the system. So that's what REST is. Now, again, there's no there's no magic bullet in these things. If you trade state for scalability, which REST asks you to do, you then have a software problem of I have to give every time I want to build something, I have to provide all the information, and that's a complex problem. It's difficult to deal with. So the way we think about it is we have a way of solving that problem, and I'll talk about what the answers are that this gives, and then I can show you how and why we do it. So everybody has legacy. Can I use my joke? Should I use my joke? I don't know if the lady's here from what was it? Southern. Yeah. She's from a alcohol distribution business, and so I said, you don't have legacy, you have hangovers. So everybody's got hangovers, and legacy exists, and it's always going to be there. But the strategy to deal with legacy these days is to make sure that it gracefully retires. If it's being used, allow it to be used. Put an API around it, because that abstracts it. People aren't hard-coded to it. You have the option to replace it. Get people to move to the API. And as you build new stuff, you can choose. Do I put my new stuff next to that old stuff in my on-premise system? Do I put it into the cloud? Or, in fact, what Anthos does, what I just showed you Google, is it basically says there's no need to make a choice anymore. You can defer it. If you just use Kubernetes as the environment, you can run it here locally next to the legacy. You can move it out by the touch of a button. So for us, cloud is not a technology. I mean, everybody's offering technologies, but cloud is not a technology. It's an economic choice. It's a capability. It's flexibility. It gives you evolvability, so you can progressively migrate things off, without catastrophes. And it's fundamentally about economy of scale. It saves you having to invest in that infrastructure, and you get something that's more valuable than you might have the capital to use. So we think longevity is important, and you need to understand how to embrace it, and it will always be there. So you've got to have it as part of your strategy. I'm also the guy who created your biggest headache, because microservices are a security nightmare. Because what you're doing is you're creating these little pinpricks in your surface, in the firewall, all these little interfaces. Who knows where they are? Who knows what the developers have exposed to the world? Who knows if there's a zero-day vulnerability that someone's just going to come in and get to the database, or whatever it might be. So again, the way we think about security is security is not a technology. Security is really a property of an architecture. And fundamentally, it's about, can I demonstrate that this system has measurable qualities that I can assert and be confident about? So what you need to be able to do is, you need to, if it's possible, can I make it so my REST endpoints are never exposed to anything that I don't want them to be exposed to? So that's not like the web, where you want every endpoint to be exposed to everyone. It's the opposite. So you have to think about the architecture differently. Can I measure these? Can I think of the relationship between sets of services as boundaries? And when you cross that boundary, you can only do it provided you give absolutely clear credentials and state to the architecture. So for us, security is all of these properties. It has to be measurable, it has to be provable, it has to be something that you can define and have confidence in, and even estimate your probability. And what is my probability of this being attacked? You need to be able to make those assessments. And for us, security is about trust. It's fundamental. Do I have confidence and trust in what I'm doing? And when you move to the cloud, you have to really be able to trust it, because it's out there and it's available to the world. So our cloud has the ability to prove trust. So how are we doing these things? Those two things I just talked about, security and legacy. The way that we're able to do this is we are able to collect services into something we call a context. And that context is it basically creates an environment in which your data has relationships to other data. So in the web, if you think about it, is one very large global flat space of everything. And that's great if you want to publish documents, publish books and pages and so on. But it's lousy if you want to build architecture and have enterprise class solutions, because I don't want to flat everything. I want to partition it into things that make sense. I want my data to exist in a world that relates it to other stuff, so that when I combine it by making 2 REST calls and compose it, that has value, it makes sense. So my data becomes information because it's contextualized, it's bounded. And that's how we solve problems. We look and build contextual architecture. And in fact, the way we do that, we can show you if you want to talk to us about it, but we can actually engineer context. And that's a new thing. It's not been possible before. Everybody promises simplification. Like I said, it's really a myth that you can't simplify. You can't make something simpler than it has to be. There's a certain complexity to everything. But it's not as simple as just saying we're going to move from monoliths to microservices. Both of them are complex, different degrees of complexity. The way we manage complexity is we collect things up into the right scale. So I told you about the choice of being on this side or this side of the axis. You shouldn't have to make that choice. You should choose which one is most cost effective, which point in that space is where you want to put stuff. That's how we do it. We have sets of services and we can deploy them as collections. And we can deploy those collections obviously on scalable cloud. And so we build things from sets, and then our solutions, this ends up becoming simpler, but no simpler than you can possibly get. So scale is another reason to move to the cloud, and everybody's cloud scales horizontally. But again, to move truly into a microservice world, into a service-oriented world, into a resource-oriented world, it's not about horizontal scale, it's about vertical scale. It's about basically saying, oh look, those things that we built for this product are valuable to other people. They can build on those, and those things become valuable to somebody else. And so you start to be able to build layered, creative architectures that evolve, that progress. And so this approach of finding the right kind of granularity and offering it allows you to build vertical scale architectures. And then performance-wise, there's horizontal scaling, but there's 2 ways of making code run fast. You can make this piece of code call this piece of code and make it as optimal as you possibly can, right? Get the very best developer to write it in assembly or whatever and make it run hell as fast as it can. But the fastest way to get from A to B is to realize you're already at B. Don't even make the journey because you've already got the answer. So if you can cache and discover in your architecture the stuff that is being reused in your organization, and that happens all the time. Like, there's a set of people in this room that was the same 15 minutes ago, and hopefully it'll be the same in another 5 minutes. That hasn't changed. Why would I ever want to determine what that set of people is unless it changes? Only when it changes do I care. So knowing that you're already at B is the fastest way of solving problems, and our technology allows us to discover you're already at B. So we can make very, very high performance architectures. So our cloud performs in all those dimensions. So this last one is it's very intangible, and it's sort of almost like faith. You have to, if what I've said makes sense, then this follows. What you're looking for is, there's this conversation about projects versus products I've heard in the C-level thinking. And what you're really looking for is to be able to create intellectual capital, intellectual property value in the business, and have that capital investment be used continuously from that point on, not to lose value. And the history of IT systems is we build intellectual capital, we get ourselves painted into a corner, and then we throw it away and we go again. That's crazy. This approach, this cloud-based, resource-oriented, contextual way of thinking about the problem gives you a web-like experience, and you get evolvable architecture. And you have to trust me, this is what happens, but this is what happens. But it's not a surprise, right? Because the web evolves. The web wasn't designed for any of the things it does today, but somehow it's just able to absorb change. So this approach gives you the same economic properties of the web. The value, the cost of change is always less than the value added when you do stuff this way. And that's, that leads to evolutionary, progressive economic value. So, keep it short and sweet. That's the CIO team. If you want to hear more from us, we've got a booth outside. People can sign up and say hi if you wanted to. Or there's Tammy here, CBO, and Randy here, and we're available to talk. And I'll take any questions.
We have some time. Someone asked a question.
Okay.
Anyone? No, we got one. Perfect.
So question for you, what do you see coming next after microservices or microservices evolve to?
Now, microservices are a step on the journey. I think what comes next is we move away from basically taking the infrastructure stack of the web, which is a publishing app, and we have general resource-oriented architecture, general resource-oriented computing. And I think that will happen. I think it's happening in small ways, but the web is an amazing invention. It's a great, fantastic technology. It's ubiquitous. HTTP is ubiquitous. Everybody uses HTTP. But there are things like security problems that are hard, even with APIs, even with REST, that if you move a little bit further, they become much, much simpler. So I think we're going to end up with a sort of uniform generalization of where REST is.
When you say they're hard, can you touch a little bit more on that and explain why they're hard and how you can make it simple?
Well, services are hard. So there's two reasons that APIs are hard. Is they're stateless, so you have to provide all the data to them every interaction, and they are context-free, so you can't trust them. You've exposed that point in your organization to every possible potential threat in the world. That's the contract you make. Great that it's available. It then comes with consequences. So managing that and layering that so that you can be defensive about what you expose to whom, so that you can share interfaces with your partners, but not necessarily have it available to everybody. And there's technologies that you can get halfway, so you can use VPNs and things like that. But who sets up a VPN between them and their? It has to be a very close customer partnership relationship to bother to do that. But there's elegant ways of solving that you can enhance services with.
A few extra minutes. Anyone have any additional questions? All right, give it up for Peter Rodgers from Dayton. All right, guys.